friends. It was so nice to have met you.
Well, it's just been on a highly interesting journey, looking into my remote controlled or gesture controlled. It can be remote controlled, but I haven't got the remote control. But it can be gesture controlled as well. So now I want to look at how the gesture control actually
Why don't you play
works.
with me?
No, I don't want to play with you. Thank you for the offer, though. I'll switch you off. So yes, she comes along and keeps giving me hints, telling me I ought to play with her, but gets a bit monotonous after a while. So how does it work? Well, if we move our hand from right across to left, we see that the blue LED lighted up at the top or lit up at the top, and if I move from left to right, it lights up as red. So in other words, we've got gesture control. It can tell which way my hand is moving. I assume because this LED emits and this detector here detects the infrared, so we can't see it, but it's there. It detects that first, it then detects this, and so it assumes that I've moved across from one side to the other. Likewise, when it goes the other way, it detects this one first and then that one, and therefore assumes I've moved the other way. The other thing it can do, of course, is gesture control. So if I come in from a distance and go up to it, then what I get is the two blue lights coming on. And if I come away, then, oops, did it wrong, come away, then I get the red lights coming on. The colour of the light depends which direction the motor goes in. So it goes in one direction for red and the opposite direction for blue. So if they're both, for example, blue, it may be that they both move in the same direction, so it probably moves forward. If they're both red, it may be that it goes in the opposite direction, so they both move away. And if one's red and one's blue, then it's going to turn, depending which one's on. So that basically is the gesture motion of this robot. So how does it work? Well, if we look at the circuit diagram, or at least not the circuit diagram, but the PCB layout, what we've got here then is the two transmitting LEDs. They do have round them a shroud, which means that they can't go sideways, they have to shine outwards. And in the middle then we've got the detector, the infrared detector, similar to you'll get on televisions and things like that are remote controlled. Also on here we've got the input. I haven't got the charger for it, so I've charged the battery off circuit. But presumably this has got a limiting chip, so if it gets to 4.2 volts it'll stop charging, and if it gets down to something like 0.3 down to 3 volts, then it'll stop supplying the circuit and cut off. We've got a little LED over here which I assume is for charging. We've got our on-off switch with what looks like a transistor here. So whether this is a voltage resistor, voltage regulator, I'm not too sure. I haven't investigated that. We've got three sort of ICs. We've got a motor driver IC, a microcontroller IC, which I assume is because it has no numbers on it, and what I assume is a memory. If we have a look then at these ICs, what we see is the motor controller is an MX1508. The only data sheet I can find is in Chinese, but interestingly enough, the sort of pinout is in English, and here we have the schematic, which shows it to be just a typical sort of H-bridge driver with two, they look like FETs oh no, they don't look like FETs. Do they look like FETs? Yeah, they look like FETs that are driving it. So 2 separate units, one for each motor. The memory chip, if we come on to that then, looks like it's an FT25H08, which seems to be an 8 megabit flash, which presumably has got all the voice data in there. It tells you what the pinout is, so we could have a look at that, but it's a bit beyond me really. When we look at the actual receiver, then on the top of it, it seems to say CHQB, which if I have a look for that, is it QB? QB or not QB? Yeah, QB. Have a look for that. Can find a Chinese, once again, data sheet for it, which gives this as its sort of block diagram. I did look up and try and find it. Somebody seemed to think it was going to be a 1738 chip, but when we look at the block diagram for that, it doesn't look similar. But when I did look up the 1838, I found it to be a very similar type of block diagram. So I assume that the infrared receiver is the same as an 1838. So how is it then we're going to detect in and out? Sideways seems quite simple, which one comes on first. But in and out, how are we going to work out the distance, whether somebody's coming towards or going away? If we have a look on the internet then, we have an instructable which uses a simple IR proximity sensor with an Arduino to work out the distance away. It can't work out whether it's gone left to right, but it's only distance, but that's all I'm sort of interested in. It's quite a clever thing that they've done, because what they do is they turn off the transmitter LEDs, measure the voltage from this receiver, which isn't of the infrared type used on televisions. It's just a 2-pin device, just looks like a normal LED, but is in fact a receiver. That then sends the voltage into the Arduino, and the Arduino measures the voltage, and the voltage coming in then determines the distance of the object away. Because they've turned off the LEDs, they can measure the objects, they can measure the distance, the ambient, before they put the LEDs on, and then when they put the LEDs on, they can then measure the distance between the ambient and the reflected ray with the object there, and work out, using the difference in voltage, how far away it is. But that depends upon voltage, and I've never had much success with this type of setup, because the ambient light always seems to affect it. Although, if you're going to switch the LEDs off, measure the ambient light and then switch the LEDs on, maybe that would work better. That's something that I'm going to have to investigate. But that then isn't the way that we can do it with our robot, because it's got digital sensors on it which can only be on or off and can't measure different voltages. So how can this work? Well, there's a chip from something, is it Vishay, which measures the, well, it doesn't measure, it has a constant pulse sent to it, and what? And the chip itself, now this is a TSSP4P38, and it senses the object using reflected light, but inside the chip it can actually change the gain of the chip. So what happens is it sends out a pulse. Well, the pulse is sent out, it detects the pulse, and when it's detected the pulse, it gradually reduces the gain that it receives until it gets down to 0. It then measures the length of the pulse. Well, the microcontroller then measures the length of this pulse, and that tells it how far away the object is. So if you've got a strong signal, you'll get a long pulse. It'll take a long time for the automatic gain control to get down and then not sense the object. Whereas if you've a weak signal, then it'll be triggered again, but only after a short period of time will the automatic gain control get to a value where it can no longer see the object. So you get this period of time is related to the distance that the object is away. So that's one way of doing it, but they find it quite slow. It only goes about 2 readings per second. So then they come on to this other chip, the TSSP 4056, and this chip then is a lot faster but works in a completely different way, in as much as it doesn't change the gain's constant, but what they do is they send out different frequencies to the chip. Now if you're bang on the frequency that the chip's looking for, then you'll get a response of a maximum response. But as the frequency moves away from the peak frequency, then the response becomes less. So what happens is they send out the peak frequency. When they get a signal, the controller tells the emitters to gradually gradually change frequency. They'll still be at the same power, but because they're at a different frequency, then the receiving chip receives less of a signal, until eventually the signal will get such that it no longer picks it up. And so the change in frequency from the peak frequency to the one where it no longer picks it up, that then allows us to estimate the distance. Seems very good, very clever, but I don't think that's the way ours is working. So what I needed to do was to try and have a look at oscilloscope. On the cathode ray oscilloscope, I found I could get bits of signals, but I couldn't actually get a proper photo to be able to analyze what was going on. So I went to a USB scope. On the USB scope then I found peculiar signals. I found that if channel 1 was one LED and channel 2 the other LED, I found that I got these sort of signals coming out which seemed to be dual signals. But when I looked at the actual receiver, I found that this just gives out constant pulses. It doesn't seem to respond in any way to these dual pulses. So are the dual pulses for real, or are they just spurious things where I've got problems with my screening on my scope or something? I found that difficult to understand. What I did do then was to connect one source to each channel. So channel 1 and channel 2 have the same source, and if they have the same source, then I would expect to get exactly the same pulses, which I've done here. But here, for example, this has got a spurious pulse on the red channel, and here we've got a spurious pulse on the blue channel, and here we've got a spurious pulse on them both. So I suspect I'm doing something wrong, but I can't work out exactly what. And if we look at this, work it out, what we find is that the frequency, despite all these odd little pulses, the main frequency works out at 38.9 kilohertz, which will be ideal for our receiver. So I tended to neglect these other pulses as something going wrong with my system. So here let's switch that back on. So here I've got the pulse from one of my transmitters, and here's the pulse from the other. tried swapping them around to see if the size of the pulse was interesting, which it is, because there, although this is one channel where this one's small, when I put it onto the other channel it still says small, so it looks like the sizes of the pulses are affected. But when I look at the output doesn't seem to be affected by the size of the pulses. Because I've only got a 2-channel scope, I couldn't actually show what's going on at the bottom of these pulses. But what I'm getting is, for example, if this is this pulse, then this pulse on the red is going to affect it here. And when I look at this output, what I get is I've got 4 cycles in 16 milliseconds, 1 cycle in 4 milliseconds, and therefore that gives me a frequency of 250 Hertz. So this output seems to just be a 250 Hertz output if it's getting signals from both of them. If I cover one over, one of the LED transmitters, then I just get this simple circuit here with these pulses missing, which is what I'd expect. And if I do this, then I can't get any response at all from the robot. It doesn't switch on either motor. If I cover over the other sensor, the other LED transmitter, and uncover this one, then I find I get exactly what I'd expect, that the signal is higher for longer, but no sort of interference. So what's going on? How does it actually work? Well, if we have a look at it, then I'll switch the sound on. You see, if I come in fast, I get the chunking, but if I come across not using distance, then I still get it thinking it's coming in, whereas if I hold it, it just does the both blues. So I suspect that a fast transfer is detected as one movement, perhaps moving away, and a slow transfer is detected as what? Coming in, because once you come in, you hold your hand there for a while. So that's all I think's happening. It detects whether the pulse is fast or slow. If it's fast, it thinks it's going away, and if it's slow, it thinks it's coming in, and that's all that happens with it. So where to now? What do I want to do now? Well, looking on the internet, everybody seems to use these little gizmos. I don't know if you can see that or not. They're supposed to be magnificent, used for colour sensing and for distance sensing.
What's your name?
It doesn't know, I don't know if you heard that, but it asked me what my name was. It's no way of knowing what my name is because it has no microphone, it has nothing to store my name in there with it. So, let's turn her off for now. So yeah, these little gizmos seem to be very good. £5 and 5p for 5, so just over £1 each. Must be good and well worth investigating. So that looks like that's going to be my next area of look, because I don't think there's any mileage in gesture control done the way that these people have done it. I think that those little boards are going to be that much better. I have come across another version of this just recently, last few days, which uses a different controller. It looks like it's the same robot, but uses a different controller, as if they've used a bigger memory chip, so they've managed to put more stuff inside it, but still use the same physical robot, and maybe even the same physical circuit board. You can ask it, it'll ask you questions, I think, and you answer A or B, and it gives you a lot more control than the original robot would, or the original controller did. So this seems to be a more advanced version of the same thing, where they've used the basic mechanics and then added more electronics. So I need to move on now. I'm glad that I've done this. It's been interesting. But where to go to now? Well, I'll have to look at these gesture control boards and see how they work. So it's bye now. Bye.